Okay, example 8. Identify simple harmonic motion in novel or what is this? Oh, there's a typo error. Unusual oscillations. Okay, uh, using a equals to minus omega square x. Okay, so what they are saying is uh, if they tell you that there's some oscillation and then the oscillation follow this formula, you should recognize that this is a simple harmonic motion. Okay, so this figure below shows a U-tube. A U-tube is a tube that shaped like a U shape, like a letter U. Okay, so it's a U-tube of a uniform cross-sectional area A containing liquid of uniform density. Okay, it's the same liquid of same density everywhere. Okay, so at first is the liquid is like this. If it's like this, then it will forever remain like this. Okay, nothing will happen. But I think somehow somebody push it down on the left tube. Then as you push down, the liquid here, origin was here, is pushed up. Okay. But the moment the person who pushes down the liquid, he let go, the liquid will not stay like this. Immediately, uh, this one is too high, it will come down. By coming down, you push this level up. Then you push up level up all the way to here. Okay, then this one will come down all the way to here. Then again, it won't remain like this. From here, the water will come down again. And then by coming down, you push the liquid up again. So what happens is that you will forever motion. This part will go up, then come down, go up, then come down. Keep on repeating forever. This one at first is up there. You'll come down and then go up, come down and go up. So both of the liquid and the both tube, you'll be undergoing oscillation. In fact, yeah, it will be undergoing oscillation up and down, up and down. Here will be down and up, down and up, down and up. Okay, then what's the question? Okay, the question says the total length of the liquid, okay, is L. So from this top, the whole length is L. Okay, then it says that when the liquid is displaced by amount x from its equilibrium position, so like this, okay, x. If here is x, here is x, from its equilibrium position, okay, dotted line, the original position is called the equilibrium position. Then the question tells us something new, something something is given, something extra. We never learned this before, but sometimes the question will tell us something new, and the something new is that they say that this acceleration in this liquid has a formula, and that is minus 2g over lx. Okay, g is the 9.81, the l is the l, so g and l are all constant. But notice that this equation, right, is the is actually is of this type. And we know that any motion whose acceleration is of this type is a simple harmonic motion. So by now, when you have read the question until this point, straight away, although the question never say that it's moving in a simple harmonic motion, but we should recognize that it is, because they give us a formula for acceleration, and this acceleration is points out that it is a simple harmonic motion, because only simple harmonic motion obey this equation. Okay, so part A. So part A, explain why the expression leads to the conclusion that the liquid is performing simple harmonic motion. So what's so special about this formula that tell us it's a simple harmonic motion? Okay, so you need to tell them two things. One is G and L are constants. Okay, so that's the first thing. Okay, you tell them G and L are constant. Therefore, A is acceleration is proportional. Because if G and L are not constant, then they are not proportional. But since G and L are constant, and they are, so A is proportional to X, which is the displacement from the equilibrium position. So that's the first thing you tell them. The second thing you tell them is, oh, there's a negative sign. So there's a negative sign in the formula. So it tells us that the A, acceleration, is opposite in direction to the displacement. So these 2 points is sufficient to say that the motion is simple harmonic motion. Okay, so that's part A. Okay, part B. Okay, so it's just filling your blank. This is the part of the answer. Okay, part B. Okay, what's the question? The question is the length of the liquid column is 0.50 meters. Calculate the frequency of the oscillation of the liquid. Okay, this one we have to apply what they have just told us, something new. They told us that A equals to minus 2G over Lx. Okay, so from this equation, how do we make use of this equation to find the frequency? Yes, we know that according to simple harmonic motion, the general formula is A equals to minus omega square x. So this thing here is your omega square. So what we do is we just have to equate this thing, which is 2G over L, to omega square. So this thing here equal to the omega square. So we find from here we can find what's the omega square, and we know that omega is 2 pi f. Okay, so can refer to the summary of all the simple harmonic motions. This is one of the formula. In fact, it's very similar formula to your circular motion, where you also have omega equals to 2 pi f. Okay, 2 pi f. Then from here we work out the frequency. Okay, it will give you 1.0 hertz.